Today we're going to be talking about the ideal gas law, which is a physical law describing the relationship of the measurable properties of an ideal gas. The equation for this law is PV equals nRT, where P is pressure, V is volume, N is the number of moles, R is the gas constant, which is 8.314 joules over mole times K, and T is the temperature in Kelvin. To show this law better, we're going to do an example. The example is a 3-liter tank contains air at 3 atmosphere and 20 degrees Celsius. The tank is sealed and cooled until the pressure is 1 atmosphere. The first question is, what is the temperature in degrees Celsius? Assume the volume of the tank is constant. So first we're going to rearrange our equation and make it where P1 times V1 over T1 is equal to P2 times V2 over T2. Since we know our volume is constant, we can take the V's out and just have P1 over T1 is equal to P2 over T2. We can then rearrange this to T2 is equal to T1 times P2 over P1. We then have to convert our first temperature into Kelvin by adding 273.15 to it, which gives us 293.15. We then plug into our equation that gives us 97.72 Kelvin. And then, since we have to find it in Celsius, we subtract 273.15 from our answer and get negative 175.43 degrees Celsius. The second question is, if the temperature is kept at the value found in part A and the gas is compressed, what is the volume when the pressure again becomes 3 atmosphere? So again, we rearrange our equation to P1 times V1 over T1 is equal to P2 times V2 over T2. But in this one, our temperature is the constant and our volume is different. So that we then have this equation, which we can rearrange into V2 equals V1 times P1 over P2. Next, we plug in our values, which were given in the question, and our answer becomes 1 liter.